Hi, this is Maggie. In this video, we're going to look at debugging and writing defensive code for a problem that uses dictionary data structures in Python. Before we get started, I'm going to quickly give you some tips for how to get the most out of this video. First, if you have problem solving with Python, read up through Chapter 8. If you don't have it, you can still learn a lot from this video. Open up idle or pythontutor.com and follow along with Python as I work. Remember, you can always pause the video and try something, or go back and watch again. There are some automated exercises in the description of this video. The exercises work with the same code or similar code to the code in the video. After you've completed the video, try the exercises to cement the concepts in your mind. Now let's get started. In the video on lists and dicts, in which we worked on a Wordle game, we created a dictionary in which the key is an integer and the value is a list of 5-letter words. The idea of the dictionary is that it stores the number of guesses required for various Wordle games. So today, for example, I had a good day, and I guessed the word spire in 3 guesses. So in the dictionary, I'd want to add spire to the list that is keyed on 3. Let me hardcode the same starter dictionary that I hardcoded in the other video here in idle. Scores equals 1 colon the empty list, 2 colon the list containing women and cabin, 3 colon the list containing Sable and Worth, 4 colon the list containing Pixie, 5 colon the empty list, 6 colon the empty list. If I ask idle to evaluate scores, it shows me the dictionary I just created. Let's check scores sub 4. That's the value associated with the key 4, and that's the list containing the string Pixie. Let me add spire to 3 by typing scores sub 3.append spire. If we unpack that, scores sub 3 is the value keyed on 3, which is a list, and so I can append to that. And we'll look at scores sub 3, and we can see the list Sable, Worth, Spire. Now, the idle debugger isn't the best at showing you collection data structures. I've opened a file called debug_dictionary.py, which contains the same code we just wrote minus the evaluations. And let's put a breakpoint on the line scores.append spire by right-clicking on the line and choosing set breakpoint from the context-sensitive menu that appears, and then turn the debugger on in idle and run this program. Now I like to click the source box in the debugger, so it will highlight the line that's currently executing in the context of our program. This is the way debuggers typically work, and it's a little easier to follow along. If we don't check that box, we can only see the line that's currently executing here in the debugger window. So execution is at the top of the window, and since I set a breakpoint, I'm just going to click the Go button. That brings us right to the breakpoint. And if we look down in the locals area, we can see scores, but notice that it's elided. I can see the beginning of the dictionary, but after key 4 and its value, I just have ... And as far as I know, and please correct me in the comments if I'm wrong, there's no way to examine that specific variable further. Making the window larger doesn't make a difference in what I'm shown, and there's no setting to change how collection types are displayed. So let's first just talk about a couple of other debugging strategies for when the debugger isn't as helpful as we might like. So first, there are always print statements. You can print specific elements in your dictionary, or you can print the entire thing. I'll close the debugger, right-click and remove the breakpoint, and then put print scores after I append spire and run the program. And that gives us the entire dictionary. When you add print statements as debugging code, you might also add an annotation so you know where in the program you are. You can also still run in the debugger, but now, where the variable section isn't showing you everything you want to see, you'll have output in the console. The other strategy, which may or may not be possible, is running in pythontutor.com. That is an excellent website that will show you a visualization of a data structure. The advantage to the visualization is it might show you something you didn't think to examine. Let's look at an example. I'm going to remove the print statement. Suppose I want to have scores for two different players. So suppose I create an empty dictionary. I'm going to copy the code I have, comment it out, and paste it and remove all of the words from the dictionary. And I'll call that empty_scores. Now suppose I have two players, Isaiah and Renata, and I want to make scores variables for each of them. And I accidentally write scores_Isaiah equals empty scores and scores_Renata equals empty scores. And then continue along, adding words to each of their dictionaries. Let me hard code some. I'll give Renata women in 3 guesses, and cabin in 4. And I'll give both of those words to Isaiah in 5 guesses. To illustrate a problem that might be noticeable while the program is running. Suppose we then want to know the number of correct guesses for each value in the dictionary for each player. I'll quickly write a function that will display that for us. Okay, so def show scores, parameter scores of type dict list returns none, docstring display the player's scores, and then annotate key of type int, value of type list, for key value in scores.items, print, and then we'll format a string which is the key, colon, and then the length of the list. So this will show the number of words solved for each number of guesses. We expect 0 words solved in 1, 2, and 6 guesses for both players, a word solved in 3 guesses and 1 in 4 guesses for Renata, and 2 words solved in 5 guesses for Isaiah. And then we'll invoke that for Renata's scores, and we'll invoke it for Isaiah's scores with a blank line between. And we'll run it. We get identical output for both players. Suppose this is part of a larger program. Either Renata or Isaiah might notice that their score is incorrect. So what's going wrong? It will be easy to see the error in pythontutor.com, so let's copy and paste the code into that website. When I do that, I remove variable annotations because Python Tutor shows those and it's a little messy. We don't need to see that. Now, if I click Visualize Execution, and click the next button a few times, hopefully I immediately see the problem. The empty scores dictionary was never copied. Scores_Isaiah, scores_Renata, and empty scores all point to the same dictionary. So when I add scores to scores Isaiah and scores Renata, they're all going to the same place. Now, if I add .copy after empty scores when I assign it, so for example, scores_Renata equals empty scores.copy, then that will copy the dict, and now each player will have their own dict of scores, and that fixes the bug. Visualizing can be enormously helpful, especially when you're just learning a language or a construct, because you may not yet know the right questions to ask in your debugging. A similar issue you might encounter is if you haven't chosen unique keys. Suppose you decide to store the scores as a person's name as the key followed by a list of daily scores. So, for example, we might have Renata as a key, and then the list 3, 4 as the value, and Isaiah as a key, and the list 5, 5 as the value. I'm sure you can imagine that a name isn't a very good key, as many people share names. So we have this small dictionary, but you can imagine it's larger with many players, and then a new player named Isaiah is added to the dictionary. And we start Isaiah off with the 2 scores this new Isaiah has gotten so far. For example, the list 2, 4. So scores Isaiah equals the list 2, 4. And if we run that in Python Tutor, we see that we completely lose the original Isaiah's list. And if we keep adding scores now for both Isaiahs, the list is going to have more elements than it should, 2 for each game instead of 1. In a dictionary, you want to make sure you've chosen a unique key. Perhaps each user has a login ID that you could use. That would hopefully be a unique value if the login code makes sense. And finally, let's write a little defensive code. Another common error is trying to access a dictionary with a non-existent key. There are a few ways we can fix this problem, and what solution you choose would depend on the requirements of the system you're writing. In the video in which we created the dictionary for the Wordle game, we used a default dictionary. Here's that code, called wordle_dictionary.py. To use the default dictionary class, you'll have to import it. So we have from collections, import default dict at the top. If you try to access a default dictionary with a key that isn't in the dictionary, the key and the default value will be added to the dictionary. So in this code, we have a key value pair in the dictionary for the key 4, but if we try to access the value at key 2, which we didn't add to the dictionary, the key 2 and the value empty list is automatically added to the dictionary. That's really useful if you don't want to have to check if a key is in the dictionary before accessing a value. But it isn't necessarily appropriate. Suppose there's an error in your code somewhere accessing a key that has no business being in this dictionary, such as 9. If you're using a default dictionary, it will get added in, and you may have difficulty finding that error in the code. It might exist in production for a long time before the error is found. So sometimes it's more appropriate to check and take an appropriate action, or throw an error. Let's look at those two solutions. I'll create a new file called defensive_dictionary.py. And let's start with a dictionary called scores, which is empty. Now I can't print scores sub 1. That results in an error because it's not in the dictionary. So we might check if 1 in scores, print scores sub 1. And no error. So if we have some activity we want to take if 1 isn't in scores, we can put that in the else clause. Maybe we want to create it if it's within an appropriate range. Maybe we want to send an error code back to some other part of the program. It depends on the requirements, but the program doesn't crash. Now, suppose it's always inappropriate to access a key that's not in the dictionary in our program, again, according to the requirements specification. Then we can let that error get thrown because it lets us know there's a programming error in our code. Or maybe we don't want our production code to crash, but we want to log the error. Then we could use the if-else, or we could enclose the code in a try block. So we might write try : and then the code that could throw the error, print scores sub 1, and then we'll catch the error and log it. We would write out to a logging file with whatever information will help us debug in the future. But let's just print something to the screen, like logging a key error. And we want to catch a key error. I know it's a key error because we saw it in the console when we let the error happen. The Python documentation has a list of exceptions you can reference so you know the correct names. So that is several strategies for you for debugging Python code with dictionaries, and also some strategies for writing defensive code. The way you handle errors is very dependent on the requirements for your system, but a general principle is that you do want to have some way to find programming errors, while still having the program continue to execute, if possible, when they occur. To practice with this, I recommend you rewrite what I've written here, as always. There are also practice exercises in the description that will go through the same code. Once that makes sense, you could work with all of the Wordle code to create your own Wordle game with scoring and, of course, error checking. Have fun with it.